Okay, I'm going to do a quick recording of the ranking tasks in Extension 1. And I recommended 1 and 3. We're going to do 1, 2, and 3, and how I would approach these. So ranking task number 1, you're asked to figure out the distance traveled. So that's one thing when you're doing ranking tasks. It's always important to read carefully and look at what you're being asked to find. So we need to find out the distance traveled, and we're going to rank them from least to greatest. So if you recall, distance is just how far you've gone. And we're looking at these moving from position 1 to position 2 to position 3. And we have the actual position values. So in the case of A, it goes from position 1, which is at 0 meters, and moves along to position 2 at 3 meters, and it continues on to position 3, which is at 6 meters. So the distance that this object has traveled is 6 meters. Likewise, in B, you have actually we'll go ahead and write down our 6 there. In B, the object again travels in one direction from position 1 to position 2 to position 3, and it goes a total distance of, it goes from 5 to 15, which gives us a distance of 10. In C, the object starts at a negative position, -5, goes out to position 2, which is way out at positive 6, and then comes back. So there's some backtracking involved in C. So you go from -5 all the way out to positive 6, and then you return. And remember, we're talking about distance. And so the initial leg goes from -5 to 6, which is a distance of 11. And then the way back, you go from 6 to 3, which is a distance of 3. It doesn't matter that you're backtracking. All we care about when it comes to distance is how far have you gone. So we have a total of 14 in situation C. In D, we have backtracking again. You go from position 1, which is at 0 meters, all the way out to position 2, which is at 6 meters. And then we backtrack to get to position 3, which is at 3 meters. So therefore the first leg had a distance of 6 meters. On the way back, we went 3 meters for a grand total of 9 meters. In E, we go from position 1 to position 2 to position 3. It's all in one line. You're moving to the right. So you just wind up going from -10 all the way out to positive 6. So therefore you've gone 16 meters. And finally, in F, we're moving from right to left this time. But remember, distance does not, the direction does not matter when you're talking about distance. All we care about is how far have you traveled. Well, if you go from position 1, which is at 6 meters, all the way to position 3, which is at 0 meters, you have traveled 6 meters. It doesn't matter that you've traveled in a right to left direction compared to, say, A, where you went from left to right. They're both the same distance. In fact, they're both the same. They would both be the least amount of distance for all these. So we would list A and F together. So A and F are the least. And then next least would be D. And you can skip a blank or you can put D right next to it. That's fine. And then we've got B next, 10. And then C at 14. And finally, the one that traveled the greatest distance is E at 16. That's how you do ranking task 1. Let's take down up to ranking task 2. Ranking task 2, we are asked to find out the displacement. Displacement is different than distance. Displacement is where did you wind up compared to where did you start. In fact, our equation, if you recall, is that displacement, capital D, I'll put it up here, I'm running out of room, capital D equals your final position minus your initial position, x sub 0. So in the case of A, you start out at position 0, you wind up at position 6, and therefore we do 6 minus 0, which is again 6. And it's positive 6. The positive is significant because that indicates the direction. We move to the right. In B, same deal. We move from left to right, we don't backtrack, and therefore my final position is 15. My initial position was 5. Displacement is just 15 minus 5, which again gives me positive 10. So very similar to the question we just answered. In C, remember we did some backtracking. So my starting position is -5. My final position is 3. So I take 3 minus -5. And therefore I wind up with a displacement of positive 8. In D, I start out, again, at position 1, and then I go out to position 2, and I backtrack to get to position 3. So I look at where did I wind up, which is positive 3, minus where did I start, which is 0. And therefore my displacement in D is just positive 3. In E, we move in one direction. We go from left to right. And therefore I just have to compare where did I wind up, which is positive 6, compared to where did I start, which is negative 10. 6 minus a minus 10 still gives me 16. Positive 16, indicating motion from left to right. Now check out F. Notice where I wind up. I wind up at position 0. I have to subtract then my initial position, which was positive 6. 0 minus positive 6 is negative 6. So unlike the last question where A and F were the same, A and F are not the same here because we're talking about displacement. And even though we traveled the same distance, they were in different directions, and therefore they are different displacements. So if I'm going to rank these, negative is always less than positives, and it's even less than 0. And therefore I would rank F first here, being negative 6. F would go first, then D at positive 3, then A at positive 6, then C at positive 8, then B at positive 10, and finally E at positive 16. That's ranking task number 2. Let's go on down to ranking task number 3. Ranking task number 3 is a motion diagram. We did this one in class, but just to clarify, we want to find out the greatest displacement in the first 3 time intervals. One thing we are assured of is that all these are moving from left to right. There's no backtracking. So we're not going to have to worry about backtracking, and we're not going to have to worry about negative values because these objects are all moving from left to right as opposed to right to left. The one thing that's very important for us to realize is we need to figure out just the displacement during the first 3 time intervals. That is key. And so therefore the way to find a time interval is to notice that the first dot is when we first start caring about the object, like when we rolled the ball across the desk. And then remember we had to wait a certain amount of time before we cared about it again, before we made our next dot. That's your first time interval. So for our example in class, it was 0.2 seconds between when we first drew our first dot and when we made our next dot. So your first time interval, I'm going to draw it as a little hump here. Okay, there's a time interval between those first 2 dots. Here's your second time interval, and here's your third time interval. So after those 1, 2, 3 time intervals, you wind up here. You started here. And therefore, to find displacement, you take your final position minus your initial position. 6 minus 0, displacement of 6. Likewise in B. 1 time interval, 2 time intervals, 3 time intervals. We wind up at 9 minus where we started, which was 0. Positive 9 is my displacement. Notice in A, I forgot to mention, you've got an extra dot there. We don't care about it. It's just extra information, but we don't need it. We only care about the first 3 time intervals. In C, 1 time interval, 2 time intervals, 3 time intervals. You wind up at position 3. You started at position 0. Displacement, positive 3. In D, 1 time interval, 2 time intervals, 3 time intervals. You wind up at position 5.5. You started at position 1. 5.5 minus 1 is 4.5. In E, you start out at position 1. 1 time interval, 2 time intervals, 3 time intervals. You wind up out at 7. 7 minus 1, positive 6. And finally in F, 1 time interval, 2 time intervals, 3 time intervals. You wind up at 4.5 minus your starting position, which was 0, and you get a displacement of 4.5. So to rank these then, C is first, it's the least. Then D and F are tied. Then E and A are tied. And then finally B is the greatest displacement. And again, in ranking tasks, it's useful to check yourself, count up through the alphabet, A, B, C, D, E, F. Yes, I've accounted for every possibility, and then My work is done.